Maxillofacial prosthesis materials. Definition: according to GPT-9, maxillofacial, pertaining to the dental arches, the face, head, and neck structures. Maxillofacial prosthetics, the branch of prosthodontics concerned with restoration and/or replacement of stomatognathing and craniofacial structures with prostheses that may or may not be removed on a regular or elective basis. Maxillofacial prosthesis: any prosthesis used to replace part or all of any somatognathic system or craniofacial structures. Introduction: maxillofacial materials are used to correct facial defects or deformities resulting from cancer surgery, accidents, or congenital defects. Maxillofacial prostheses are difficult to fabricate and have a relatively short life of 6 months to few years in service. Despite availability of materials like silicone which are best suited for fabrication of maxillofacial prostheses, the high costs, especially in the Indian scenario, are a limiting factor in its usage. Due to economical considerations, acrylic resins, which are not the best material, are still used more often in the fabrication of maxillofacial prostheses. Classifications. According to Beumer, it is classified as acrylic resin, acrylic copolymers, polyvinyl chloride and copolymers, chlorinated polyethylene, polyurethane elastomers, silicone elastomers, and new materials like silicon block copolymers and polyphosphophosenes. According to Ansavis, latex, a tripolymer of butyl acrylate, methyl methacrylate and methyl methacrylamide, vinyl plastisols, silicon rubbers, and polyurethane polymers. It can be also classified as extraoral materials and intraoral materials. Extraoral materials involving acrylic resin, vinyl chloride polymers, polyurethane, and silicon. Intraoral materials, silicones, and polymethyl methacrylate. Ideal properties. Ideal physical and mechanical properties: high edge strength, elongation, tear strength, softness compactable to tissue, low coefficient of friction, glass transition temperature, specific gravity, surface tension, and thermal conductivity. Odorless, non-inflammable, and no water sorption. Ideal processing characteristics: chemically inert after processing, dimensionally stable during and after processing, easy to repair and refabricate if needed, long shelf life and working time, retain intrinsic and extrinsic coloration during use, short processing time, and low processing temperature. Ideal biological properties: it should be non-allergenic, cleansable with disinfectants, color stable, inert to solvents and skin adhesives, resistance to growth of microorganisms, and it should be compatible with supporting tissues.